Okay, so I decided to go through the Desmos review here. So number one, we want to reflect over the y-axis and then the x-axis. So on the first slide here, number one is asking us just to simply label the points. Right, so the points of our green quadrilateral here are going to be 0, -2. Okay, we have 2, -2. We have 5, 3, or 5, 2. 5, 2. And then we have 2, 4. Okay, those are our 4 points there. Okay, if we want to reflect over the, let's see if we can zoom out a little too, maybe. If it will let us. Okay, so we have 0, 2, 2, -2, 5, 2, and 2, 4. We want to sketch the image of the reflection of the green quadrilateral. Okay, so that was all very delayed. We don't want to go that far back. Our rule for reflecting over the y-axis is going to be, right, x, y. Okay, and since we're flipping over the y-axis, that's the vertical axis, so we're flipping left and right. So that means we're going to change the sign on the x value and leave the y value the same. Okay, so if we go to our coordinates here, we had 0, -2, so -0 is simply 0. So that one's going to stay 0, -2. Okay, the next one is 2, -2. So if we flip that across, it's going to be -2, 2. -2, -2. Sorry, -2, -2, right? The y value doesn't change. It doesn't go up or down. Okay, 5, 2, we flip that over. That's going to be -5, 2. Okay, and then 2, 4, you flip it across. It's going to be -2, 4. Okay, so we can use the rule. The other way we can do this is we can count on the graph. So 0, -2 is on the y-axis. So when you reflect it across, it's going to stay the same because it's on the line of reflection. You can imagine folding a piece of paper. If a point is on the crease that you're folding across, the point on the crease isn't going to move. So 0, -2 stays the same. The point 2, -2 is 2 to the right of the line of reflection, so we need to go 2 to the left. So that was our -2, -2. The point 5, 2 here is 5 to the right of the line of reflection, so we need to go 5 to the left. So that was our -5, 2. And then the point 2, 4 is 2 to the right, so we need to go 2 to the left. So that was our point -2, 4 there. Okay, and then we can connect those points together. And there's our reflection. So that was the reflection across the y-axis. Number 3 here is asking us to reflect across the x-axis. So if we write our rule for reflecting across the x, that's going to be x, y. So the x-axis is the horizontal axis. So when we reflect over it, we're reflecting up and down. So the y value is going to change sign and the x is going to stay the same. So our rule was x opposite of y. So we're reflecting the blue image, the reflected image. Okay, so if we're using these points here as our pre-image. So again, our x values stay the same, so 0 is going to stay 0. And then we change the sign on the y, so -2 becomes +2. Okay, -2, -2, so that the x is going to stay -2. We switch the sign on the y, that becomes +2. Okay, -5, 2. So -5 stays the same. We're just flipping it down. So -2. And then -2, 4, it's staying -2, but we're going to flip it down 4, so it's going to be -2, -4. Okay, and again, we could also simply count our points here. So let's get the red one here. Okay, so 0, -2 is 2 below. We want to go 2 above. Okay, so we put a point there. This one's 2 below. We go 2 above. Okay, this point here is 4 above, so we got to go 4 below. This one's 2 above, so we have to go 2 below. And then we can simply connect those points. And there's our reflection. Okay, reflected over the y, and then we reflect it over the x. Okay, so that gets us to question 4 here. And let's answer on theirs. So it says write a composite function, write a composite transformation. So whatever comes first has to be the second thing we write, and then whatever comes last is the first. So the last thing we did was we reflected across the x-axis. Okay, and what we reflected across the x-axis was the reflection over the y-axis. So it's the reflection over the x-axis of the reflection over the y. So this would be our composite transformation. This is what we did first. Right, this is what we did first. We reflected over the y, and then we took that reflection over the y and we reflected it over the x. So it's the reflection over the x of the reflection over the y. Okay, so you just have to switch the orders there. Okay, let's go to slide number 2. Okay, and let's erase this here. Okay, slide number 2 wants us to do a 90-degree rotation, so we're using the same points as before. So let me go to slide 1 here. I'm simply going to copy and paste the points from slide 1 because they're the same points. Okay, so we have 0, -2, 2, -2, 5, 2, and 2, 4. So we're going to do a 90-degree counterclockwise rotation. So our rotations of 90 degrees and 270, we have a 2-step process. The first step is to switch the coordinates, so make the x the y the x. And the second step is to figure out what quadrant it's going into so we can find the signs. Okay, so the first thing I'm going to do here for my 90-degree transformation, or 90-degree rotation, is I'm going to switch the points. So 0, -2, I'm going to switch to 2, 0, because again, I don't care about the signs at this point. I'm just doing step 1. Okay, 2, -2, don't care about the signs. Switch the 2 and the 2. That's going to be 2, 2. Okay, 5, 2 is going to become 2, 5. Okay, and then 2, 4 is going to become 4, 2. Right, so there's our switch the x and the y. And the second thing is to find the signs. Okay, so 0, -2 is down here on the y-axis. If we go 90 degrees counterclockwise, we're going to be on the x-axis. So that's going to be this point right here. Okay, and the signs for that point are going to be positive 2, 0. So we're going to leave that at positive 2, 0. Okay, 2, -2 is right here. If we go 90 degrees, we're going to be in quadrant 1. The signs there are positive, positive. So we should have a point here at positive 2, positive 2. 5, 2 is in quadrant 1. If we go 90 degrees counterclockwise, we're going to be in quadrant 2. The signs for quadrant 2 are negative, positive. So we're going to make this -2, positive 5, which would be right here. And then 4, 2, or 2, 4, I'm sorry. Okay, is in quadrant 1. We rotate it 90 degrees. It's going to be in quadrant 2, which is negative, positive. So -4, positive 2. Okay, so this is on the y-axis. It goes to the x-axis. This point is in quadrant 4, so it goes up to quadrant 1. And then these 2 points are in quadrant 1, so they go to quadrant 2. So we have positive, positive 0, and then positive, positive, negative, positive, negative, positive. Right, let's connect these points. Okay. So we've rotated 90 degrees counterclockwise. Okay, the next step is to sketch the graph of the reflection of the blue image over the line y equals x. So I'm going to draw in the line y equals x in purple here so we can see it. So that's the line with a slope of 1 and a y-intercept of 0. So that purple line there, that we're going to reflect the blue one over it. Okay, we have a rule for reflecting over the line y equals x. And that rule is to simply switch the coordinates. So our rule here would be xy is going to go to yx. So xy simply going to go to yx. Okay, so if we look at our point 2, 0, we're going to switch it to 0, 2. Okay, 2, 2 is still going to be 2, 2. It's going to be on the line of reflection. Negative 2, 5 is going to go to 5, negative 2. And then negative 4, 2 is going to go to 2, negative 4. Okay, and then we can plot those points here in red. So again, 0, 2, 0 is going to go to 0, 2. Okay. 2, 2 is going to stay on 2, 2 because it's on the line of reflection. Negative 4, 2 is going to go to 2, negative 4. Right, it's going to flip across this way. And then negative 2, 5 is going to go to 5, negative 2. And then we can connect our points. And there's our reflection of the blue quadrilateral over the line y equals x. Okay. And then the last step here, they want us to write our composite transformation. So it's going to be, we did the rotation. Whoops, let's pick this one. Okay, the rotation, 90 degrees around the origin. 90 degrees about the origin. And we took that and we reflected that across the line y equals x. So we did the reflection across the line y equals x of the rotation 90 degrees around the origin. So this would be how you would write your composite transformation. All right, let's go to slide number 3. Okay, we want to reflect across the line. So we control paste in those original points. We had 0, negative 2, 2, negative 2, 5, 2, and 2, 4. We want to reflect across the line x equals negative 2. So let's draw that line in so we can see it. So x equals negative 2 is we're going to go to negative 2 on the x-axis, and it's going to be a vertical line. All the x values here are negative 2. All right, let's do it in a different color other than blue. How about purple? Okay, there's the line x equals negative 2. Right, negative 2, 0, negative 2, 1, negative 2, 2. All the x values on that line are negative 2. All right, so we need to count here our points. So let's go back to the blue one here. So this first point here, 0, negative 2, is 2 to the right. So we need to go 2 to the left of the line of reflection. That's going to be negative 4, 0. Okay, this point here, 2, negative 2, is 4 units to the right of the line of reflection. So we need to go to the line of reflection and go 4 to the left, and that's going to be negative 6, 0. Okay, 5, 2. Okay, that's going to be 7 units to the right of the line of reflection. So we need to reflect it across. So it needs to be 7 units to the left of the line of reflection. So 1, 2, 3, 4, 5, 6, 7. That's going to be negative 9. So again, and the y value is staying the same because we're just flipping right and left. So this is going to be negative 9, comma, 2. Okay. And then this point 2, 4 is 4 units to the right. So we need to go 4 units to the left. 1, 2, 3, 4. That's going to put us at negative 6, 4. Okay. And there's your reflection over the line, x equals negative 2. Okay, if you fold across there, the green and blue points would line up. All right, and then they're asking us to now rotate 180 degrees. So we have a rule for rotating 180 degrees. So our rule for rotating 180 is going to be xy goes to negative x, negative y. So we're going to take those blue points and rotate 180 degrees. So we simply need to change the signs. So if we look at our points, we have negative 4, 0. That's going to become 4, 0. Negative 6, 0 is going to become 6, 6, 0. Right, negative 0 is just 0. Okay, and then 9, negative 2. Okay, and then negative 6, 4 has become 6, negative 4. Okay, and then we can plot those points there. So, right, we have 4, 0. Oh, I'm sorry, these should be negative 2. Right? These should be negative 2. Okay, that didn't make sense, right? So, we should have 4, 2. We should have 6, 2. Okay, this makes more sense. I'm sorry, 4, 2, 6, 2, 9, negative 2, and then 6, negative 4. Okay, that's so negative 4, negative 2 becomes positive 4, positive 2. Negative 6, negative 2 becomes positive 6, positive 2. Negative 9, positive 2 becomes positive 9, negative 2. And negative 6, positive 4 becomes positive 6, negative 4. Okay. So if we graph those points there, right? Negative 4, negative 2 is going to become positive 4, positive 2. Negative 6, negative 2 is going to become positive 6, positive 2. Okay. Negative 9, positive 2 is going to become positive 9, negative 2. And then negative 6, positive 4 is going to become positive 6. I'm sorry, negative 6, positive 4 is going to become positive 6, negative 4. Okay. And there would be our, right, 180-degree rotation to the red one. Okay. And then if you want to write your composite function here, so the first thing we did is we reflected, all right, so capital R, big R, reflected over the line x equals negative 2. And then we took that and we rotated it, so little r. All right, we rotated 180 degrees around the origin, on the point 0, 0. Okay, so we took the rotation of the reflection. All right, slide 4 here. All right, so we want to reflect over the line y equals 2. So if we draw in the line y equals 2, that's going to be a horizontal line at 2. All the values on that line are, all the y values are 2. So that's why we call it y equals 2. Okay, so we want to reflect across that line. Okay, so let's copy and paste our originals in here. So the first point, 0, negative 2, is 4 units below the line of reflection. So we need to go 4 above. So that's going to be 6. Okay, 2, negative 2. Well, let's type it in as we go. So that's going to be 0, 6. So 2, negative 2 here is also 4 units below. So we need to go 4 above. So that's going to be 2, 6. Okay, the point 5, 2 here is on the line of reflection, so it's going to stay on the line of reflection, so it's going to stay 5, 2. Right, if it's on the crease that you're folding, it stays on that crease. 2, 4 here is 2 units above, so we need to go 2 units below. It's going to fold down. The other points fold up. This one's going to fold down. So that's going to be the point 2, 0. Okay, and then now we can right, connect our points here. And there's our reflection over the line y equals 2. Okay, we now want to rotate 270 degrees. So this is just like 90 degrees. We're going to use our two-step process. The first thing we're doing is switch the coordinates. So let's switch all of our coordinates. 0, 6, we're going to put 6, 0. Okay, 2, 6, we're going to put 6, 2. Okay, 5, 2, we're going to put 2, 5. And then 2, 0, we're going to put 0, 2. Okay, and now we need to find out the sign. So step 1 was switch the coordinates. Step 2 is find the signs. So we're rotating the blue one. Okay, so the first one was 0, 6. So that's on the that's on the y-axis here. We're going 270 the way around. So that would be 90. This would be 180. This is going to be 270. So that's positive 6, 0 on the x-axis there. So we're going to leave it as positive 6, 0. 2, 6 is in quadrant 1. So if we go 90 degrees, we're in quadrant 2. If we go 180, we're in quadrant 3. And if we go 270, we're going to be in quadrant 4. So the signs there are positive, negative. So positive 2, negative 6. I'm sorry, 6. Yeah, that's what okay, 6, negative 2, right? That was it. 2, 6 was the original. So let me, right? So we switch the 2 and the 6. It becomes 6, 2, right? 6, 2. And then we want positive, negative. So positive 6, negative 2. Okay, 5, 2 here is in quadrant 1. So if we go 90, we're in quadrant 2. 180, we're in quadrant 3. 270, we're in quadrant 4. Okay, so we switch the 5 and the 2, so it's 2 and 5. And then it's positive, negative because we're in quadrant 4. So positive 2, negative 5. Okay, and then the last one, 2, 0, here is on the x-axis. So if we go 90, we're on the y. If we go 180, we're back on the x. I'm sorry, 2, 0 is on the x-axis. So if we go 90, we're on the y-axis. If we go 180, we're going to go back to the x. And then 270 is going to put us back on the y. So that's 0, negative 2 is our sign there. It's down. So 0, negative 2. And then we can fill in our lines. And there's going to be your 270 degree rotation with 3/4 of the way back around. Right, and then if we want to write a composite function, so first thing we did is we reflected across the line y equals 2. Yep. Okay, and then we took the rotation 270 degrees around the origin of that reflection. So the rotation 270 degrees about the origin of the reflection over the line y equals 2. So we reflected over the line y equals 2, and then we rotated that. So it's the rotation of the reflection gives us our final image. Okay, the next one here, slide number 5, is translations. So again, we have the same original coordinates on our quadrilateral. So we have 0, negative 2, 2, negative 2, 5, 2, and 2, 4. All right, we're going to translate this according to the vector negative 4, negative 5. That means we're going 4 left and 5 down. So the way I would do this is simply count. So we're going to take this point here, and we're going to go 4 left, 1, 2, 3, 4, and then 5 down, 1, 2, 3, 4, 5. 4 left, 1, 2, 3, 4, down 5, 1, 2, 3, 4, 5. Okay, so that puts us at negative 4, negative 7 for the first one. Negative 4, negative 7. And then negative 2, negative 7. Okay, and then let's take this one, go 4 left, 1, 2, 3, 4, and then 5 down, 1, 2, 3, 4, 5. That's going to put us at 1, negative 3. Okay, and then this one here, 1, 2, 3, 4 left, and then 5 down, 1, 2, 3, 4, 5. And that's going to put us at, negative 2, negative 1. So that puts us at negative 2, negative 1. Okay, the other way you could have done this is you could have simply added the horizontal shift to the x values and the vertical shift to the y values. So 0 plus negative 4 is negative 4, and then negative 2 plus negative 5 is negative 7. 2 plus negative 4 is negative 2. Negative 2 plus negative 5 is negative 7. All right, 5, we're going left 4, so that's 1. Right, and then down 5, that's negative 3. Left 4 is going to put us negative 2. Down 5, 4 minus 5 is negative 1. Okay, so there's your translation. Okay. Next one, we want to translate the blue figure. So we want to take all the points and go right 1 and then up 3. So 1, 3. So that's right 1, up 3. So I'm going to, again, you can add them to the previous point or you can count. So I'm going to go, I'm just going to count 1 right, 1, 2, 3 up. That's going to be negative 1, 2. Okay, we're going to go right 1, up 3. That's going to be 2, 0. Right 1, up 3. Right 1, 1, 2, 3, up 3. And then here would be our translated figure. Okay, the red one there. But again, you could just use the previous points if you want. So you have negative 4, 7. So if we go right 1, up 3, that's going to be negative 3, negative 4. Okay. Right 1, that's negative 1, negative 4. Right 1, up 3, right? So right 1, that's 2, up 3 is 0, so 2, 0. And then right 1, up 3 for the last one, that's negative 1, 2. Okay, and those were our 4 points there, right? Negative 1, 2, 2, 0, negative 1, negative 4, negative 3, negative 4. Okay. The last one wants the, if we combine them, instead of doing the composition of the first one and then the second one, if we just went straight from the green to the red, we'd go in left, 1, 2, 3 left, and then 2 down. So if we combined them, right, we would be going, and let me write this here, right, we'd be going left 3 and down 2. Okay, but you can also get this from counting here, right? So 1 plus negative 4 is going to be negative 3, and then 3 plus negative 5 is negative 2. Right, so if you go left 4 and then right 1, you've gone a total of left 3. If you go down 5 and then up 3, you've gone a total of just down 2. So there would be your transformation there, your translation. This composition translation written as a single translation. Okay. All right, let's go to slide 6 here. So this one is asking, what is the line of reflection? Okay, so the green preimage is reflected over what line to transform it to the red? Okay, this we should be able to do visually. So the idea is the line of reflection is halfway between the 2 points that you're, the preimage and the image. So if we took this point here in the red, that's going to be, or the green first, we'll do the green first. So that's negative 4, 0. Okay, and then it's going to negative 2, 0. Okay, and then if we want to pick another one, we can pick one more here. So this is 2, 2 on the green. Okay, and that's going to negative 8, positive 2. Okay, and on this one, we can clearly see the line of reflection halfway between those points is going to be the line x equals negative 3. But if we didn't know that, we can find the midpoints of these 2 points. So midpoint formula is the average of the x and the average of the y. So x1 plus x2 over 2. So negative 4 plus negative 2 over 2. Right, and then 0 plus 0 over 2. And so that's going to be negative 6 divided by 2. That's negative 3, 0. Right, so the midpoint there is negative 3, 0. Okay, and then you can find the midpoint of the other one. So that's going to be 2 plus negative 8 divided by 2. Then your y's would be 2 plus 2 divided by 2. So the first one there is going to be 2 plus negative 8 is negative 6 divided by 2 is negative 3. And then 2 plus 2 divided by 2 is 2. Okay, and then so you know that's another point. And so we know the only line here that's going to have those 2 points would be the line x equals negative 3. If it was more, and these are the ones you're going to have on the test. So, but if you did want to find one that wasn't a vertical or horizontal line, you would then take these points and then find the line. So you would use these points to find the slope, right? Rise over run, right? So, 2 minus 0, right, over negative 3 minus negative 3, right, which becomes a plus, right? So you get 2 over, and then negative 3 plus 3 is 0, which means there is no slope. So since there's no slope, you know it's a vertical line. And so our x values here are negative 3. So the line would be x equals negative 3. Okay, but these ones you should be able to visually figure out. You shouldn't have to do all that extra math. You shouldn't have to do the midpoint. You shouldn't have to do the slope. You should be able to visually solve it out. Okay, if we want to look at the other one here, so reflection of the green pre-image is reflected over what line to get the blue image? That would be the line y equals 2. Again, that should be a visual thing. You shouldn't have to do all the math. Okay, it should just be a visual thing. And we're not going to have ones on the test where you need to do the slope and the midpoint. They should all be visual. Okay, let's go to slide 7 here. Okay, it asks if a figure is translated according to the rule xy goes to x plus 4, y minus 3, what is the translation that will move the figure back to the original location? So if we went right 4 and down 3, so right 4, so let's just say we had a point 0, 0. We went right 4 and down 3. The question is, how do we get it back to the original one? Well, we have to go left 4 and up 3. So this would be x comma y. Right, and we would go left 4, so that's x minus 4, and then up 3, y plus 3. Okay, and if we wanted to write those as vectors, so if we wanted to write the original rule as a vector in case they show us a vector on the test, it would have been written as the big T for translation, and then 4 for your horizontal shift, 4 to the right, and negative 3 for your vertical shift down 3. And so if you wanted to get back to the origin, we'd have to go left 3, so you'd put negative 4, and then up 3, you would put 3, positive 3. Okay, so this is if it's in coordinate notation. This would be in vector notation. Okay, pretty simple there, I think. All right, slide 8 here. What quadrant is the point translated to, or into? It really should say into. Okay, the point A is at negative 2, 1. So that's this point here. We translate it according to the following rule. Xy goes to x plus 4, y minus 3. So 1, 2, 3, 4 to the right. And then 1, 2, 3 down. That's going to put us in quadrant 4. Right? This would be quadrant 3. This would be quadrant 2. And this one's quadrant 1. So our point here, if we translate negative 2, 1, is going to go 4 right, down 3. So we're going to end up in quadrant 4. All right, slide number 9. Point A prime, 3, negative 2 there, is the image of point A, 4, 1. Under a translation, what is the image of negative 3, 3 under the same translation? So we need to find the translation first. Okay, so A is going to be the point 4, 1 here. A prime is the point 3, negative 2. Okay, so to get there, we have to go left 1 and down 3. So our translation to get there, right, we're going from 4, 1 okay, 2, 3, negative 2. right? So to get there, our translation is going to have to be left 3. So that's a -1 for our horizontal shift, and then -3 for our vertical shift. We have to go left 1 and down 3. Okay, we then want to use the same. So again, and on the test, don't mess up. You're going from A to A prime. So you're going from 4, 1 to 3, -2. Don't switch it around. You're going from A to A prime. A prime is the image of the pre-image, image of the point, right? The pre-image is the original, and you're going from the pre-image to the image. So you're going from 4, 1 to 3, -2. Okay, then it's saying what's the image of -3, 3. So we're starting with -3, 3. That's our pre-image, and we want to find the image of that. So we're using this rule here that we came up with because it's under the same translation. So we're going left 3, left 1, that's going to put us at -4. And then we're going down 3, that's going to put us at 0. So the point -3, 3, if you go left 1 and down 3, you'll be at the point -4, 0. Okay, so that would be your answer, -4, 0. Right, and the last slide here simply wants us to describe or just name the rigid transformation. So we have, again, reflections, rotations, and translations are our 3 options. Okay, the first one's a reflection, right? You're reflecting this one actually is going to get reflected over the y-axis. But all we need to say for this is reflection. This one would be a reflection. Okay, B and B prime are equidistant from the y-axis. C and C prime are on the y-axis. And then A and A prime are the same distance there away. So that's a reflection. Right, this one here, it's not changing its orientation. So that's going to be a translation, right? You're not rotating it. We're not reflecting it. The orientation stays the same. So that's going to be our translation. We're simply shifting the blue one right and down. Or if you want to look at the other way, we're shifting the purple one left and up. So since it's not changing orientation at all, that's just going to be a translation. All right, and we could come up with the rule here. The rule would be 1, 2, 3, 4, 5, 6 to the right, and 1, 2, 3 down. So if we wanted to write that, right, it would be right 6 and down 3 from the blue to the purple. Okay, and then the last one here is a rotation. This one would be a 90-degree clockwise rotation from the blue to the red, from X, Y, Z to X prime, Y prime, Z prime. So this one would be a rotation. Okay, and that's it. If you can do everything on there, you should easily ace the test, and it should take you 20 minutes or so. Okay, shouldn't be long if you know what you're doing. Please let me know if you need help, though. I'll be online each night here.